Sasha and Keone think that the equation y equals x squared divided by 4 times p will represent any parabola with a vertex at the origin. To test their conjecture, they will derive the equation using the Pythagorean theorem and the definition of a parabola. Also, they will be working with a graph that represents any parabola with a vertex of 0, 0. Rather than being told a specific distance between the focus and the vertex, the distance is unknown and is represented by the letter p.
Now we're going to try to test your conjecture. You think that the equation for any parabola going through the origin, with the focus p units above the origin, is going to be y equals, you want to write down your conjecture?
X squared over 4p.
Okay. Now, when I opened this graph, Sasha said, oh, this looks like the first lesson we did. Because why?
Because you didn't give us the number, like the numbers?
You didn't, it's not on a graph.
Okay, the grid marks are gone.
Yeah.
The grid marks.
But
Grid
what's
marks,
different
that's
about it than the first lesson?
That you already gave us
It's
the
already
focus
drawn
and the
out.
directrix.
I gave you the focus and the directrix. What else?
And the point, like we know that this point is going to be equal distance from there and there.
Yep. And did you notice it's on an XY coordinate grid
Yes.
system? You just don't see all the
It's not
grid
just a black
markings.
or
Yeah.
blank paper.
And I did that because I was thinking it might help you think about the general case when that distance is p. So Sasha's already marked the distance from the origin to the focus. Could you label that as p?
P.
So that
Yeah, so that's p.
P.
P distance.
so label anything else you know now that you know the distance from the origin to the directrix is p. What else do you know?
We still know that the distance from our point and our directrix is the same distance between our point and our focus.
Need to do all the lines.
That's good.
So now instead of doing all of our a squared, b squared, c squared stuff, we just have our equation right there.
Well, we're going to try to prove that equation. So I
we
want you
do all of our-
to see if
Y plus p.
you can derive it like you've been deriving the others. And
Okay.
we'll see if that conjecture is correct.
So since we don't have it, we're going to say it's going to be y plus, it's plus, right, on this one?
Yeah.
So y plus p here, and then y minus p, because we know that it's above the origin, but we don't know by how much, and we know it's below the origin, but we don't know how much. So that's going to add whatever units p is, and that's going to subtract whatever units p is.
Well, let's stop for just 1 second. I want to just make sure, maybe in a different color, if one of you could outline each of these. So for the y plus p, where's the y, the distance of y?
For y plus p,
Yeah,
the distance of y is right here.
okay. And then where's the distance of p?
That little bit.
Should I do different color or just
circle
circle it? That's the distance of p.
Okay, and then y plus p?
Y plus p is this entire thing.
Okay. Now on the other side, where's the y? So if y minus p, I think of you've got some total distance y, and you're taking off a distance p.
So y is still from right here to our origin,
Okay.
and then p again is right here.
And then what part represents the distance y minus p?
This 1 minus p,
And why did you change your mind there?
because our y is the full distance from here to here.
Okay. Now, Sasha, do you agree with what he
I
said?
do.
Okay.
All right, and we still know that that's going to be our x, and then we know that this is going to be y plus p, because that distance to there is the same distance from that to there.
Sasha and Keone began by identifying a right triangle so they could use the Pythagorean theorem. They applied what they learned previously to find the length of each side, but this time they worked with an unknown distance between the focus and the vertex, which was represented as p. Sasha and Keone said that the distance from a general point on the parabola, x, y, to the directrix is y plus p. That's because the distance from the point to the x-axis is y units, and the distance from the x-axis to the directrix is p units. Together, this distance is y plus p. The distance from the point x, y to the focus is also y plus p because of the definition of a parabola. Sasha and Keone found that the length of the vertical side of the right triangle is y minus p. That's because the distance all the way to the x-axis is y units. Then, they subtracted the distance between the focus and the vertex, which is p units. This leaves the distance y minus p. Finally, because the point x, y is x units to the right of the origin, the length of the horizontal side of the right triangle is also x units. Now that Sasha and Keone have found the lengths of the sides of the right triangle, they can apply the Pythagorean theorem to find the equation for this general parabola, which represents all parabolas with a vertex at the origin.
So we know y minus p squared plus x squared equals y plus p squared.
Write it out so you don't get confused with the
y
decimals.
minus p, y minus p, y squared
So weird.
minus yp plus
P squared.
p squared plus x squared equals y squared plus 2yp plus p squared and this is minus 2yp. So then we subtract y squared.
You're having so much fun, aren't you?
Yes. Add 2yp. Subtract p squared. X squared equals 4yp. Square root of 4.
Do you want to get y by itself? Yeah, you do. Okay, so because we've been doing it where the y is by itself, not the x, so we're going to do y equals x squared over 4p.
What do you think? Does it fit your conjecture?
It
Ba-ba-da.
does. Wait.
Oh,
Circle
wait.
the other one. Circle the other one.
That one too?
Those are two equations.
Sasha and Keone's conjecture was correct. The equation for any parabola with its vertex at the origin is y equals x squared divided by 4 times p. This equation can also be expressed as x equals the square root of the product of 4 times y times p. In the next episode, Sasha and Keone will talk about what this equation means.